Have you ever wondered if death, as we know it, is the ultimate end? And does the universe too share a similar fate? Imagine for a moment the concept of death. We all understand it in one way or another. The finality it brings is universal, transcending cultures, languages, and species. It's a shared experience that bridges the gap between all forms of life, a common thread woven into the very fabric of existence. But what does this finality really mean? In the grand scheme of life, death is a full stop. It's the conclusion of a story, the end of a journey. It's the moment when the heart ceases to beat, the brain stops firing its electrical impulses, and life as we know it ceases to be. This is the finality of death, an irrevocable, irreversible cessation of life. But is there a similar finality in the cosmos, an end to the universe as we know it? Just as the life of an organism is marked by birth, growth, and eventually death, so too it seems, is the life of the universe. Born in a fiery explosion known as the Big Bang, our universe has been expanding and evolving for over 13 billion years. Stars have been born, lived, and died in spectacular supernova. Galaxies have collided and merged, creating new stars and celestial bodies. But what happens when the universe reaches its own version of old age? When the stars cease to shine, the galaxies stop spinning, and the cosmic background radiation cools to absolute zero. Just as life on Earth faces an inevitable end, so too might the universe. This is not a whimsical speculation, but a serious consideration by many scientists today. They propose that the universe might not only face a finality similar to death, but that it might do so in a way that mirrors the finality of life. A similar finality might also be in store for our universe, a theory known as the Big Freeze. At the turn of the 21st century, astronomers studying 42 supernovae stumbled upon a startling discovery. Let's take a step back for a moment. What's a supernova, you might ask? Well, imagine a white dwarf star minding its own business in the vast cosmos, siphoning off gas from its celestial companion. This activity causes an increase in its mass, sparking a runaway nuclear reaction and ultimately a spectacular explosion. That's a supernova for you, a celestial fireworks display of the grandest scale. Back to our tale. These astronomers, armed with their telescopes and data, were not just marveling at the cosmic spectacle. They were looking for answers, peering into the heart of these supernovae to unravel the mysteries of our universe. Through their meticulous study, they noticed something strange. The light from these supernovae was weaker than expected. What could possibly cause this, they wondered? The answer was as astounding as it was terrifying. The universe was expanding at an accelerating rate. Now, this wasn't entirely a surprise. The idea of an expanding universe had been around since the early 20th century, but the thought of it accelerating, that was new, and it had profound implications. For if the expansion of the universe was indeed speeding up, it suggested an eventual and inevitable fate, a big freeze. The Big Freeze, as the term suggests, is a rather chilly prospect. It refers to the theory that the universe will continue expanding until it becomes too sparse to support the processes that create heat and light. In essence, the universe would slowly cool and darken until it reaches a state of absolute zero, a time of eternal cosmic winter. This discovery was a game changer, suggesting that our universe might be headed for a cold, dark end. But what does this Big Freeze really mean? Well, let's delve into the concept. The Big Freeze is a theory about the death of the universe. It's a process that's taking place right now as we speak. The universe is expanding, and not just expanding, but accelerating in its expansion. This is the very discovery made by those astronomers studying supernova in the late 1990s. As galaxies drift further apart, the universe becomes increasingly isolated and cold. Now imagine a cup of hot coffee sitting on your desk. Given enough time, that coffee will cool down to the room's temperature. This is due to a principle known as entropy, or the second law of thermodynamics. The heat from the coffee spreads out until everything is the same temperature. In the same vein, the universe is like a giant cup of coffee. As it expands, the heat gets spread out, thinning until it's evenly distributed. The stars will burn out, galaxies will drift apart, and the cosmic temperature will cool. This is what we refer to as the heat death of the universe. But don't worry, this won't happen anytime soon. We're talking about a timeline that stretches so far into the future, it's almost incomprehensible. We're talking billions upon billions of years from now. Yet it's a sobering thought. With the big freeze, there's no dramatic end, no fiery explosion or sudden end. Instead, the universe will slowly and quietly fade away into darkness and cold. The stars will die out one by one until there's nothing left but black holes and dead stars. The big freeze is a theory of silence and isolation. It's a theory of a universe that, given enough time, will spread out its warmth until there's nothing left but a vast, cold, and lifeless cosmos. In essence, the big freeze is the universe's ultimate end. The realization of such an end brings with it profound implications. The big freeze, as chilling as it sounds, is an existential theory that has the potential to reshape our understanding of the universe and the future. Let's delve into these implications. The first is the existential crisis it inevitably introduces. The idea that everything in the universe, including us, is heading towards a state of inactivity is a thought that can be unsettling for many. It challenges our understanding of existence, and it forces us to confront our mortality on a cosmic scale. The second implication is the impact on our understanding of the universe. Traditionally, we viewed the universe as a dynamic entity, with galaxies colliding, stars forming, and life evolving. However, the big freeze suggests a universe that will eventually run out of energy, becoming a cold, dark, and lifeless place. This paints a starkly different picture from the vibrant cosmos we're accustomed to imagining. Thirdly, the big freeze has implications for our future. If the universe is indeed expanding at an accelerating rate, as the study of supernovas suggests, then we're heading towards a future where the night sky will be devoid of stars, galaxies will drift apart, and the universe will become an isolated and desolate place. This vision of the future, although billions of years away, is a sobering reminder of the ephemeral nature of our existence. However, it's important to remember that the big freeze is just one of many theories about the fate of the universe. It's based on our current understanding of physics and our observations of the cosmos. As our knowledge expands, this theory may evolve or even be replaced by a different one. In the grand scheme of things, the big freeze theory serves as a humbling reminder of our place in the cosmos. It challenges us to appreciate the beauty of the universe while it's still vibrant and teeming with life. The big freeze paints a rather bleak picture of the future, but it's a possibility we cannot ignore. So, what have we learned about the big freeze and its significance? We started our journey by discussing the finality of death and the universe. We examined how, just like living beings, stars too have a life cycle. They're born, they mature, and eventually they die, often in a spectacular supernova. This cycle of stellar birth and death is a fundamental process that shapes the universe. Then, we dove into the discovery of the big freeze, a concept that emerged in the late 20th century. Astronomers studying 42 supernova made a startling discovery. The universe, they found, wasn't just expanding, it was accelerating in its expansion. This suggested a chilling conclusion. Given enough time, the universe would continue to expand and cool until it reached a state of maximum entropy, or disorder. This is what we refer to as the big freeze. To understand the big freeze, we broke down the theory. We explored how the universe's constant expansion leads to a decrease in energy density. As the galaxies move farther apart, the rate of star formation slows down, and eventually, the stars burn out. The universe becomes a cold, dark, and lifeless place, a state of ultimate finality. We also touched on the implications of the big freeze. It's a theory that forces us to confront our mortality on a cosmic scale, but it also highlights the beauty and preciousness of life. Knowing that our existence is fleeting in the grand scheme of the universe makes our time here all the more meaningful. While the big freeze might seem a distant concern, understanding it helps us appreciate the universe's grandeur and our place within it. So let's continue to explore, to learn, and to marvel at the cosmos, for the universe is a grand stage, and we are but brief players in its infinite play.